Hello, I'm Declan McIntosh presenting movement tracks for the automatic detection of fish behaviors in videos. Global warming poses a dire threat to ocean ecosystems as they exist today. Video studies of animal behavior have potential to indicate population stressors which can lead to early intervention. Due to the amount of available underwater video and the required magnitude of annotation, an automatic tool is required. We propose a novel end-to-end behavior detection framework which detects sablefish startle events in organism tracks. Previous work on automatic data collection from underwater video focused on organism detection and counting, but this lacks higher-level ecological data. Further, these previous works cannot be trivially extended to these more complicated contextual events. Organism behavior detection also poses a difficult intra-class detection problem similar to those discussed in Ionesco et al. Modern state-of-the-art event detectors such as RemoteNet are a logical alternative to our proposed method, but provide a lower level of annotation and, as we will show, lower performance. Our proposed method first takes in 4-second clips of video at 10 frames per second. Object tracking for the sablefish class is then performed using a fine-tuned YOLO v3 detector. Associations are then made using a cost-minimizing Hungarian algorithm based on detection centers. Tracks of less than 2 seconds are added as they contain too little temporal context. Then, 4 domain-specific metrics are generated to constrain classification of the behavior. We then use an LSTM time series classifier to generate classifications for each captured track. An LSTM classifier was chosen to fully capture the important sequential temporal relationship of the generated metric. The LSTM classifier generates track-wise predictions of startle events. Finally, for comparison with existing state-of-the-art event detectors, we take the maximal positive track prediction for a clip as the clip-wise classification. Now let's dive into a little bit more detail on each of our metrics. The first 2 metrics describe the motion of the fish in the frame by polar direction and speed. These are chosen to represent the rapid acceleration and change of direction commonly associated with startle events. Next, we track the aspect ratio of the bounding box as the fish behaviors can be indicated by the morphology of the organism during and around the event. There is another common feature of startle events where the organism will curl up into a C shape and change direction. This is caught by this metric. Finally, we track a custom local momentary change metric. We convolve the LMCM metric over each color channel of the clip through its spatial and temporal shape. This metric is generally associated with rapid motion of startle events. We take the mean value of this kernel's response within each detection in order to gain the final LMCM value. Let's discuss the data set used and created in this paper. All data for our dataset was collected from a stationary video camera permanently deployed at 620 meters of depth at the Barkley node of Ocean Network Canada's first Neptune Marine Observatory. We collected all data between September 17th and October 24th, 2019. In association to our proposed method, we provide a new dataset to hopefully spur additional research into this domain. The created dataset provides 3 levels of annotations. First, we provide 600 images and bounding box annotations, which we use to fine-tune our YOLO v3 detection model. We also provide 892 annotated 4-second clips for the existence of startle events. Finally, all tracks contained within the previously annotated clips based on our implemented tracking method were similarly annotated for startle events. This multi-level approach to annotation allows for additional levels of evaluation in this paper and future research, and allows more varied implementations to be compared more directly. Speaking of comparison, let's move on to our results. We compare our novel end-to-end method to an existing state-of-the-art event detector, RemoteNet, for clip-wise classification. Notably, RemoteNet does not generate higher-level track-wise classification, so no comparison can be made. In clip-wise metrics, we show that our method outperforms RemoteNet. There is significant degradation from track-wise to clip-wise classification for our proposed method. This is due to lost tracks and increased sensitivity to noise from the maximal conversion to down-sampled track-wise to clip-wise classification. To summarize our content in this paper, we first discussed the level of abstraction we achieve with our novel end-to-end track-wise detect. Because of this, we are able to generate more semantically rich tracks. In addition to this, our method outperforms an existing state-of-the-art detector when down-sampled to their level of data abstraction. We hope our efforts can provide tools for researchers to determine the effects of climate change at an early point through ecological behavioral triggers before population decline or movement. Further, higher-level annotations at large statistical levels will allow for novel research in ecological and biological fields. The described dataset, we hope, will engage further research into this domain, accelerating the development in tools for ecological research. Future work should seek to extend these methods to additional behaviors and associated domain-specific metrics.